Hello students, welcome back. So in this session, I'm going to be talking about pandas, more specifically slicing, iterating, indexing, and sorting. Okay, the first thing you want to make sure is that you have pandas installed. So run this command, copy this, come over here, and I run this command. So when you run this command, if you have pandas installed as I have, you are going to receive this message: requirement already satisfied, and bunch of this message right here, similar messages. Okay, if you don't have pandas installed, then it's going to take anywhere between 4 to 5 minutes before your pandas gets installed. Now let's import our pandas. Assuming that you have installed your pandas, let's import our pandas now. I import my pandas and I'm creating an alias. This is called creating an alias. Basically, I'm just creating a shorter name for pandas. And in literature, you're going to find as PD. And then I import my warnings and I want to suppress all my warnings. Okay, now make sure you have this file in your directory for this to work. Now this file you can obtain from the same location where you obtained this particular notebook. So let me show you the content of this file, and which is this right here. It's a CSV file, and you can open up in a notepad. And these are the content, okay? Name, age, city, experience, experience 2, salary, passport, bonus, hours. So this is my column name, okay? And these are the corresponding values. So I created a few sample of them over here. Okay, assuming you have this file now, moving on. Let's talk about slicing. So slicing allows you to access a subset of your data frame. Okay, you want to access a subset of your data frame, and the concept of slicing is exactly same as it was in list, in tuples, and in string. There was the same concept. Okay, so slicing. So in this case, you specify your start index, colon, stop index, and step size. Default value of your start index is 0. The default value of your stop index is end of your data frame, and the default value of your step size is 1. So if I run this, it's going to give me my df first. I print my df first, which is right here, and then I'm specifying. I'm saying, hey, slice the rows from index 2 to index 6, and this is the convention I'm using, 2 colon 7. I am not specifying this step size. Okay, by default, it's going to do step size as 1. So it prints rows 2, 3, 4, 5, 6. As you can see, it's printing rows 2, 3, 4, 5, 6. It prints those indexes. Okay, this is what it printed right here. Right there is what I wanted. So it printed this over here. Okay, now let's use our step size now. So slice rows from index 2 to index 8 with my step size 3. All right. So slice rows from index 2 to index 8. So my index 2 would be right here. This is my index 2, right? Index 2 to index 9, which is actually it's not going to include 9. It's going to go up to 8. Okay, this is my end index right here. All right. Now remember, step size is 3. So it's going to go 1, 2, and 3. So it's going to do 2, right? 2, and it's printed 5. 5. And the next one is going to be 1, 2, and 3. And you see that it did 8. So this is how you're able to get certain rows. Now we come to iloc, loc, iat, add. So these are the ways, these are little method that allows you to access certain part or certain values of your data frame. So iloc is an integer position based selection. This one is loc is a label based selection, and fast is a iat is a fast integer location based a scalar accessor. It allows you to access certain scaled values. And likewise, you add. It's a fast label-based scalar accessor, much faster when you only need a single value. So if these iAdd and add is so fast, why do we need this iloc and loc? Well, when you need multiple rows or columns, use loc, dot loc or iloc position based. Okay. On the other hand, if you need only single value, only working with a single value, which is a scalar value, then you use your dot at or dot I at. Remember this. Now this one, I at and at, they tend to be a lot faster. So anytime when you work with a single value, or another word is a scalar value, work with I at or at. So let's start with iloc first. So let me just remove this. Let's go step by step. Run this, and there you go. So I'm printing my data frame, and I'm accessing a single row by index. df.iloc1. So it's going to give me a single row by index. So it's this one actually prints name Bob, age 30, and his hours 50. You can see this is right here, index row, right there. Okay, I'm able to access that information right here using iloc1. Okay, now what if I want to access a specific cell? Let's say our row 1, column 2. So row 1, which would be this one right here, and column 2. Now remember, your indexing starts with 0. Okay, so 0, 1, 2, which is right here, city. So I want to access this value. Okay, so the way I'm going to do, df iloc 1 comma 2. Okay, so if I run this, it's going to give me Los Angeles. Okay, Los Angeles right here. So this one is iloc 1 comma 2. This is your 1, row 1, okay, and column 2 right here. This is 0, 1, 2, 3, 4. Indexing for column starts with 0. Now I want to access multiple rows and columns. So I want to access the first 3 rows and the first 2 columns. So in other words, I want to access first 3 rows, which would be right here. Okay, first 3 rows and first 2 columns. So the first 2 columns is right here, this one. So I want to access this part. Okay, this is what I want to access. So this would be df iloc 0 colon 3, okay, comma 0 colon 2. And if I run this, it gave me that answer. So as you can see, this is exactly what I got. Okay, this right here, this right here is same as this right here. Oops, sorry, right here. Okay, I want to access multiple rows and columns now. So now I want to access rows with index 3 to index 6 and columns with index 2 to index 4. So let's run this. So this is what I want to access. I want to access my rows with index 3 to index 6. So index 3 to index 6, which is right here, and my columns with index 2 to index 4. Now remember, columns is index 0, 1, 2. So this is my 2 all the way up to 2, 3, and 4 right here. So in this case, the data that I'm trying to access is this right here. Okay, this is the data that I'm trying to access. All right, this is what I want to access. So this will be 3 colon 7, 2 colon 5. This will be my row, okay, and this will be my column. And let's come back. So let's come down. Let's come down, and as you can see, it accesses that value. Houston 10, Houston 11, Nan 33, San Antonio 66. Okay. Now I want to modify a value. Let's say I want to modify Alice's age. Now Alice's age, let's say, where exactly is Alice? Alice's age is right there. Okay, I want to modify her age to 26. So I'm going to say df iloc 0 comma 1 equal to 26. So this way I'm able to access the value and modify it. So I run this and I print my df, and you can see Alice's age has been modified to 26. Initially her age was 25. Okay, now it has been modified to 26 because of this right here. Okay, so this way you can modify values. Now let's talk about loc. Okay, so I show you 4 use cases of loc. So let me just remove this. All right, let's run this, and there you go. So in this case, I'm trying to access a direct, like using my index label. I'm trying to access the record using index label. So in this case, I'm accessing get the data. I'm trying to access the data for row with index 3. And the way I do this thing is df.loc3 right there. Okay, so it gives me data, which is a row 3, a row with index 3. And this is the one right here. This one right here. You see this data gets printed over here. This is my data right there. Okay. Let me just put this thing, Control C, put it over here. So you can see the separation between them. And there you go. So now you can see that this dflog3 is this right here. Okay, this one is exactly same as this right here. Okay, David 40, Houston 10, 10, 9000, 846, 7100. 40, Houston 10, 10, 9000, 846, and so on and so forth. Okay, now Now I want to filter rows. I want to filter rows based on some condition. And let's say the condition is this, that get me all employees from Chicago. Okay, let's say this is my condition, that get me all employees from Chicago. Okay, so get me all employees from Chicago. So first you specify your condition, and this is how you specify your condition. You say df square bracket and write the name of the column, city, and then you say double equal to Chicago. So that's going to filter. This is my condition. Okay, condition is this, like get me all the or get all the records or all the employees from Chicago. So I got this, and then I'm going to type df.loc and put my condition over here. Okay, so this is the syntax for your loc. And then when I run this, it's going to give me Chicago right here. So it gives me everybody for Chicago. See that? This is my Chicago. And Chicago, there's a one person, Alice, and also Charlie. Alice and Charlie are only two people from Chicago. It gave me that. Now, filter rows plus pick columns. This one allows you to filter rows and pick certain columns. Now I'm saying get me the name and salary of employees who work in Houston. Okay, so people who work in Houston, get me their name and salary. So I specify my condition, dfcd equal to Houston. This is same as this, almost similar. Okay, I'm just change the name of the city from Chicago to Houston. And I'm saying that I only want these columns, names and salary. I don't want any other columns. So I type print df.loc square bracket condition comma columns. This is my condition and this is my column. I'm just separating is you can actually put these two directly inside that, but your code will look very hard to understand. In order to make it readable, I'm actually putting it separately like this. Okay, now when I run this, it gives me those people. So people, name and salary of people who live in Houston, and it gave me name and salary for people who live in Houston. And you can see people who live in Houston, these are the two people, David and Eva. David and Eva. Okay, it gave me their name and salary. So it gave me name and salary, Houston. So let's see, name is Eva, right? Is one, and David. Name and salary. Okay, now if salary is missing, now you can actually update the value too. Now using the same logic over here, you can also update the value. So basically what I'm doing, I'm saying if this condition is satisfied, then update the value for this column to this value. Okay. So if the salary is missing, if there's an NAN, fill it with 5,000. Okay. This is what I want. If the salary is missing, fill it with 5,000. Now you can see that there is a salary missing right here, NAN. So we want to fill this thing with 5,000. Excuse me, 5,000. So my condition is this. Okay, and then I'm actually using this syntax right here. Okay, this is the syntax I'm using. So log df.log condition comma salary equal to 5,000. So it's going to fill up the column salary with 5,000 if this condition is satisfied. You run this, and if you come down, I print my df again, and you can see the salary has changed now. Charlie salary initially was nan, right? It was nothing over here, but now it's showing 5,000. So this way you can actually change the salary for somebody. Okay, then comes IAD. Let me open up a few cells. So in this case, I'm printing my df again, get my df, and then I'm printing my df, and I'm saying get me a single value. So get me the value with that has column with index 1 at row with index 2. So my value at column with index 1, which is this right here. Remember index 1, this is my index 1, and my row with index 2, which is right here. So this intersection with this, okay, will be 35, and it prints 35 right there. Okay, now I'm changing Eva's bonus, okay, to 3000. Now Eva's is in row 4 column 7. So I'm changing some entry on row 4 and column 7, which is right here, okay, which is right here, row 4. This is my row 4 right here, and column 7, 0, 1, 2, 3, 4, 5, 6, 7 right there. So this will be 2555. I'm changing this to 3000. Okay, that's what's happening over here. So if I run this and I print my df again, and now you can see that value has been changed. So Eva's bonus, Eva is where? Eva is number right there, and bonus has changed to 3000. 3000. Initially it was Eva's was where was Eva? Eva was 255. Okay, now it has changed to 3000. Then comes your at. All right. So I read my CSV, I print my DF, and then I'm changing. Okay, actually, I'm sorry, I'm trying to get access. I'm trying to get salary for row with index equal to 0. So this will give me the salary for the row that is at index 0. So this is my row at index 0, and I'm trying to get the salary, and the salary is 7,000 right here. So I print my DF right there. I print my that not DF, but I print that value, and it gives me 7,000 right there. Okay, then I print my hashtag, prints my hashtag. Okay, and then I print. I actually update. Actually, before I print, I update my bonus. There is somebody named bonus, and he's at row with index 4. So index 4 is right here, and I want to update the bonus to 3000. So see, I updated the bonus, and I print my DF again, and that has been updated to 3000. Okay, iterating over a data frame. Sometime you have to go through every single rows. Maybe you want to perform some operation. So there are two options. There's a iter tuples, and there's a iter rows. Now iter tuples is faster and more memory efficient, and iter rows is a little bit slower. So I'm going to be using iter tuples. Iter tuples. So let me just print my df first. Let me comment this thing out, run this, and there you go. So first thing what I'm doing, I'm actually printing my df. Okay, so it prints my df right there. Then I print a bunch of hashtags. It prints my hashtag right here. And then all I'm doing, I'm just going through every single entry using my df iter tuple, and I'm printing my row right there. Okay, so it prints out all my rows. You can see it's printing the first row, second row, third row, fourth row, all the way up to the 11th row, which is a row with index 10. Okay, it prints out all my rows. All right, step 2. Let's say, what do I do with these things? Like I printed out, okay, great. Now what do I do with this thing? Let's say you want to send email to all people, okay, whose age is more than 30. So this is your boss comes to you and he says, hey, I want you to send email to all the people whose age is more than 30. So now you can use this iter tuple. You can say for row in df.iter tuple, if row 2, now remember your indexing starts with 0, right? So row 2 would be, this is 0, this is 1, this is 2 right there. Okay, this is your index 2 right there. So row 2, which is age column, is at index 2, okay, is greater than 30, then you print this message. So let me run this, and there you go. So it's going to send anybody whose age is more than 30, it's going to send this message, email, you, whatever your name is, are qualified for discount, call us. So it's going to say you, Charlie. Now row 1 would mean that value at index 1. Now remember, this is index 0 right here. This is index. By the way, this when I'm saying index 0, this is happen to be the same name. Uh, Basically, what I'm saying is this, that if you look at the row wise, this whole thing is your index 0. This thing, this right here is index 1, and this right here is index 2, and so on and so forth. So I'm trying to get the value row at index 1, which is right here, name. Okay, so it's going to print you and the name over here are qualified for discount, call us. So you, Charlie, are qualified for discount, call us. Then comes indexing. Sometimes we want to create our own index. A lot of time it happens that you want to actually have your own index. Okay, so let me comment this thing out first. So I print my original data frame. Okay, it prints all my data frame right there. And then I wanna, when I look at this data frame, this is my index right there, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are your indexes, right? This is your index right here. Maybe I don't want this my index, okay? I want to have my own custom index. And you realize that, I want to use this as my index, okay? I want to use this as my index. So you can do that too. You can actually use this command, df.setIndex, and name of the column, passport, comma, in place equal to true. And then you print your df again. When you print your df, you can see your index has changed now. Your index is this. Okay, so index went from this right here to this now. Now this is a new index. Okay, you can change index this way. Now you want to reset your index. Let's say you change your index and you realize your mistake. You say, you know what, I don't want that index. I wanted to change it back. You can actually change it back by using df.resetIndex. Okay, so if you run this, it's going to reset it back to the original state. Now maybe you want to have your own custom index. So you can have your own custom index. Okay, let me just print out this. Okay, in this case, I'm actually using my own custom index. I'm calling this employee 001, employee 002, employee 003. I'm using my own custom index. So first I create a list, okay? I create a list, and in that list I populate the elements with like this, employee I03D, okay? This is simple logic that's actually populating the list. If you want, you can print it out, you can see what the list is. I print it out and you can see this is my list right here. Okay, I want to actually use this as my index. So instead of saying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I want to use employee 01, employee 02, and so on. So I want to use this as my index. So first I create this list right here. Okay, and I create this list using this little syntax. All right, and then I can change my index now. df.index equal to L index. This is my L index right here. Okay, and I'm changing it to L index. And then I print my df again. And when I print again, you see my index has changed right here. So sometimes you may actually need your own custom index. You don't want to use index from here. You don't want to use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want to use your own index. So this is one way you can do that. Sorting. Now you can also sort values. So let's say you want to print your data frame in a sorted manner. So you can sort by age. Let's say I want to print my data frame sorted by age, and you want ascending to be true. So if you run this, it's going to print everything based on your sorted value by age. As you can see, it's sorted by age 22, 23, 25, 26, and so on and so forth. It's sorted everything. You can also do sorting by multiple columns. In this case, I'm saying sort by city and age. Okay, city first and then age. Now, if you see city, same city, okay, people living in the same city, then sort by age. But when you sort by age, make it ascending. But when you sort by city, make it descending. Okay, so if I run this, and if you come down, you can see some people live in the same city. Look, San Diego, San Diego, San Diego, Helen, Helen, Helen. Well, they're the same people. Let's look at Houston right there. Houston, Houston. Two people live in Houston, and they are sorted by increasing age. You see, 22 and 40. Two people live in Chicago, 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 and look, their age is 25, 35. So it's sorted. First, it sorts based on the city, and then it sorts based on the age. So that's what you mean by city comma age. Okay, ascending equal to false comma true. So city is false and your age is true right here. Okay, so it's ascending true. All right, thank you.